Airspeed Indicator senses dynamic pressure by measuring the difference between static pressure inside the case and total pressure inside the flexible diaphragm. Higher dynamic pressure expands the diaphragm like a balloon when the aircraft speeds up and shrinks the diaphragm when the aircraft slows down. A mechanical link between the diaphragm and the pointer drives the needle to display indicated airspeed to the pilot. In the atmosphere, density and static pressure decrease as altitude increases. For demonstration purposes, let's assume that at low-level altitude, static pressure has a value of 3 units, the middle level has 2 units, and high level has only 1 unit. For a stationary aircraft in the middle level altitude, static pressure from the static port is 2 units, and the total pressure from the pitot tube is also 2 units. Since the aircraft is not moving, there is no dynamic pressure coming from the pitot tube. The airspeed is 0 knots, since both pressures are equal and cancel each other out. For an aircraft in flight, the dynamic pressure expands the diaphragm as it enters through the pitot tube. Let's assume that dynamic pressure has a value of 5 units, which results in 100 knots of actual indicated airspeed. But what if the static port gets blocked and the aircraft climbs to fly at a higher level where the static pressure is 1 unit? The static pressure in the case does not change because it's trapped inside by the blocked static vent. The dynamic pressure also does not change because the aircraft's actual airspeed is still 100 knots. But the static pressure inside the diaphragm decreases from 2 to 1. Consequently, the difference between total pressure in the diaphragm and the static pressure in the case is less than actual. Thus, the airspeed displayed is less than actual airspeed. So the instrument incorrectly underreads in a climb. What if the aircraft descends from the middle level to fly in the lower level where the static pressure is 3 units? Again, the static pressure in the case does not change because it's trapped inside by the blocked static vent. The dynamic pressure also does not change because the aircraft's actual airspeed is still 100 knots. But the static pressure inside the diaphragm increases from 2 to 3. Consequently, the difference between total pressure in the diaphragm and static pressure in the case is higher. Thus, the airspeed displayed is higher than the actual airspeed, so the instrument incorrectly overreads in descent. What if the aircraft climbs or descends with a blocked pitot tube? In this case, the total pressure in the diaphragm gets trapped and remains constant. The airspeed is incorrectly displayed to be higher when the aircraft climbs, since the diaphragm further expands as the static pressure inside the case reduces. The airspeed is incorrectly displayed to be lower when the aircraft descends, since the diaphragm further collapses as the static pressure inside the case increases. Learn this mnemonic to help you remember these errors. Thanks for watching.